Hello and welcome everyone. In this video, we are going to deploy a simple Flask application in through the ECS, which is Elastic Container Service. Now, we know what is a container orchestration principle. We know how to create containers, but we also need to understand there are a couple of other services apart from the Kubernetes that you can use in order for you to manage your entire container orchestration ecosystem altogether. And for that, we are going to explore this AWS Amazon ECS today. So, in order to deploy your containers into the ECS, you need to have the containers ready with you first of all. So either you can create the containers and put on ECR, which is a repository by the AWS itself, or you can use Docker Hub to have it. So if I have to specify, so I already have a repository in the Docker Hub where I have created a simple Flask application and have deployed my Flask application into this uh, into our Docker Hub itself. I don't think I do have to log in per se because sometimes it does happen with the way that the entire ecosystem has been. Okay, so what we have to do is we'll first go across and we'll uh, go and use our Docker Hub account. So I've already created a Docker Hub account where I have pushed my Flask application. We'll just go ahead and use this Flask application for the purpose. So simply go ahead and I'll just log into my okay, so this is my simple Flask application, and since it's a simple Flask application, it is running on port number 5000 for that matter. Anyway, so we are going to use this application in order to deploy. So just in case if you guys are worried about, you guys can visit Prashant Day slash Slamper Flask app, and you can use this application to deploy or practice your ECS or any other orchestration services altogether. So the first thing is that we'll first go ahead and create a cluster. So choose a reason based upon your requirement. We'll just simply go ahead and write sample Flask app cluster, right? So this is what I'm naming it as. Now, when you talk about the infrastructure, we have different sort of the infrastructure with us, which is the AWS Fargate, EC2 instances, or any external instances you want to use. So EC2 instance, we already know if we want to deploy and if we want to manage the entire orchestration by ourselves, which means that we have to deploy containers into the EC2 instances, provide all the configurations and all. That will become a lot of tasks because we need to handle the large workload with us. If you have some external resources where you are having it and you want to configure it into the ECS, you can do that. Or AWS Fargate is like a serverless where you don't really have to worry about the containers and the nodes. It's something everything is being handled by the Fargate itself. So it will, take care of the containers, execution of the containers, managing of the containers, health, every single thing is being done with the help of the Fargate. So you can use the Fargate with the ECS. You can use the Fargate with the EKS, which is the Kubernetes service by the AWS as well. So anyway, we are going to configure with the AWS Fargate. Pretty easier to set up. So we went ahead. It will take few minutes of time to basically go across and create a cluster. So the first process is that it is basically going to go across and create a cluster. Once the cluster has been created, uh, we'll start by configuring our repository, like I mean the container that we basically put. So this is one of the image which we have already put it across. So we'll basically go ahead and configure this particular image to kind of work with our cluster. It'll take few minutes of time. Once this has been created, we'll simply go ahead and look for the other processes. Okay, as you can see, it says a cluster has been created successfully, which is pretty good. So now you can see, like, we have, the cluster is created. Now, all of these things are already specified. One of the two interesting thing is the services and the tasks. So tasks are the actual running containers which you want to, what? So task can consist of one container or multiple container, which means one task or multiple tasks altogether. And so these are like the actual, component which is running for you. Now, services are the one which basically make sure that these number of tasks are running. So let's say if you have a container running on port number 5000, which is one task which is running. Now, services are the one which make sure that at least one, or let's say whatever the number that you have specified, that many instances of the containers are basically running or not, right? So that is the work of the services, and the tasks are the actual ones, container which are running. So first of all, go across and configure a task, sorry, a task. So just specify the task that we want to create. It says, do you want to create a task definition name? Okay, so we'll just simply go ahead and we'll create a task group. Okay, so now you can see we don't have a task definition here. We can simply go ahead and create a task definitions here. Okay, so let's first go ahead and create a task definition. Okay, so just name it as hello flask task. And so task definition is the one where you define your containers and the all relevant, information required for your application to run. So we'll first go ahead and specify the application we are running. Okay, so it's running on the tag as latest. So I will simply put across my image URI and can specify this is going to my hello flask app. Okay, now we know this is the container port we have to specify. So remember, uh, my container is running on port number 5000, so I have to specify the container port as a 5000, right? So this is critically very, very important to understand. You know, so flask port, I'm just specifying the flask port altogether. Now you can have, let's say if this container is running on multiple port, you can keep on adding multiple port, and that can also work. Okay. Uh, Anyway, so we have this one task container, we configured it. If you want to do any more, configuration about the logs and everything, you can simply go ahead and do it. Otherwise, just go ahead and, click on create. Okay, my bad. It automatically takes only the, everything in small. So you have to specify the flash port there. Okay, now it also specifies what is the, resource allocation you want to have. So conditional, it's like how many CPUs you want for it. You can specify the hard limit for the memory, the soft limit for the memory as well. So we are not going to have any more configuration. Just go ahead and click on create. So at least we know our task has been created, which is going to run on the port number 5000. Now we'll come back to our runner task, and if we actually look into it, okay, we'll just simply refresh this page. Okay, the task page. Now if I actually go across, I'll find out the hello task is running. It has the okay, it will automatically create a division. It's fine. We'll simply go ahead and okay, the platform net test everything. We go ahead and create a task. So now the task is has a starter. So obviously it's provisioning, which means it's basically starting. Uh, and this is like the actual working, yeah, of it. But however, we need to create a services so that it makes sure that if anything goes wrong in the task, let's say the task has an error because of which the container is out, the services are the one which will make sure that even if there are error and the container is down or the task is down, the services will create another replica of the task and will make sure the application is available. So services are the one which makes the entire application highly available. So we'll go ahead and create a service there. Okay, so we'll simply choose everything manually. So we just specify the service class task, and we'll simply go ahead and it'll ask me for the simply go ahead and specify this task. We'll go ahead and create it. Okay, which means it's getting created. Now it will take some time before the task is getting created, right? It will require some time to get created. Now here's an interesting thing if you notice. Okay, we created a task separately and we are also provisioning a service separately. So these are the two different things. So when we're creating a services, if we wanted to create a task in the first place, it was just one specific task without a service which got created. And in this case, when we created a service, we made sure the service along with the task was created altogether. Okay, so these are the two basic difference that you have to understand. The second one, in this case, has a service, through which the task got created. In the first case, it's just the task which got created altogether. So if you don't want it, okay, you can just simply stop this task. Okay, this task will get stopped. However, the one which was running through the services, you can find out the service is now up and running, and you can say one by one task is running all together. So we have basically specified one task, which is pretty easier to do. So just a difference on that part itself. So now if you want to understand the task, so you can simply go ahead and look into the task which is being executed. Like I said, it's still a deployment process, still in a progress. It will take a few seconds more time for the deployment to work. If you noticely, look into it, you'll find out the public IP of the task got created, right? Now, public IP will be the one through which we are basically going to, access this particular cluster. So, access this task altogether. So, if I actually copy the public URL, try to open the public URL with the port number 5000. So, and if we have done everything perfectly fine, we'll find out the hello world is there. That is something we're expecting. Now, there is another thing with this. So okay, which is pretty good that we somehow managed to, execute and, run across our, ecosystem. We made sure that it is running on port number 5000. However, when we actually go into a real life basis, we realize that this is just not enough because you might be exposing your services on port number 80 and your container might be running in a completely different port number altogether. So the problem, if you face this kind of problem, we don't really have a port mapping kind of feature in the ECS. So now to have this port forwarding or port mapping kind of thing, we have to use something called as the load balancer for that matter, which means we have to go ahead and externally first create a load balancer and then configure that particular load balancer with that. So I'm basically going to go across and look for the load balancer. Okay, because now you can see like it's running on port number 5000. Let's just make sure that it runs on port number 80 and not on 5000. So go across and click on create a load balancer. We'll make sure it's an application load balancer uh, for obvious reason because web application. Okay, write the name of the load balancer, test flash ECS, right? I'll make it internet facing because that is something which needs to be accessed by the people all around the world, which is okay. And then we'll choose you know, the groups. Now here's an interesting thing. Okay, the most interesting thing is like, uh, talking about the target group. So we need to create a target group first. So let's go ahead and create a target group. right? And if you find out in the load balancer, in normal scenarios, when we just used to deploy a replica into the multiple instance, we used to choose the instance type because we are mapping it through the EC2 instances. However, in this case, we are not going to map it with the EC2 instances, but with an IP address because ultimately our service is running on the this specific IP address. So we'll go ahead and map it with the IP address, and we'll specify the target group name. Okay, flash tg, right? And then we'll point it to the port number 80. Rest everything is fine. We'll go ahead, point on next. Now this time is asking, like, from which VPC subnet we want to point it, right? Particularly very, very important for us to understand from which VPC subnet, and you can find out this private IP is the one through which we want to point through it. So you go ahead and specify this IP address on the VPC subnet, um, you know, on which port, you want the traffic to route. So obviously we know that our container is running on port number 3000, right? So we definitely would like to, sorry, my bad, 5000. So make sure that, the service is running on for 5000. So the idea is that our application will get the load balancer will get a traffic on port number 80. It will send it to a target group, which is configured to map with the port number 5000 of this specific IP address. Right. So we go ahead, create the target group. We already have a flash digit now. So now if you go back here, and if you can, you know, refresh it, you'll find our flash TG is there. Go ahead and create it. And this is like a port number 80. I'm pointing it out that hey, from port 80 it should go to port number 5000. Okay, which is good. If you have more of the containers, more of the port numbers to point, you could have just simply go ahead and point every single thing over there. Then we go ahead and click on create load balancer. Now our load balancer got created. One critical point we always need to make sure is that the LOT zones. If you see the LOT zones, we have AP South 1C, 1A, 1B, right? You have to make sure when you're creating the TG, and especially when you have, like, pointed out your registered target, it needs to be in one of the zones out here. I've seen in past people are just randomly choosing the zones. Let's say you chose the zone as like 1A and 1B. But you never chose 1C. However, you're configuring the target which is actually created on 1C. Okay, in those kind of scenarios, your application will just not work. So you have to keep in mind, these important things altogether. Right? Okay, it will take some time, I think, for it to get executed. Perfect. Now I can see that my load balancer got provisioned, and I can see the DNS name of it. So if you try to open the DNS name, which is pointed with port number 80 and redirected to port number 5000. So if we have configured everything correctly, we should be seeing the hello world, the exact same thing that we were expecting. So pretty easy. So in this video, we basically started with the ECS. We created a task in the ECS, configured the task with um, the Flask application, and one of the Dockerized Flask application that we already had in before. We basically created a service, okay, making sure that application is always available. And then when the service got started at port number 5000, we wanted to make sure that it is available. On a different port number, like the port number 80 and stuff. So for that, we configured our load balancer for it, and now we have the application running on port number 80 already. So that is all with the ECS. We'll see each other in the next video. Thanks a lot. Bye bye. Take care.